Hello, my chemistry minions. Video number 7. Electrolytic cells in particular. This should be quick, and guess what? It's done. So when we're done with this, we will make sure we can compare and contrast the two electrochemical cells, being voltaic versus electrolytic. Remember, electrolytic needs energy to go. So right off the bat, I'm going to see this direct source of energy. And that is, in this case, a battery. So wherever you see a battery up top instead of a voltaic cell, this is what's going on with the electrolysis. And this one is copper chloride or electroplating. This is something Monaco can do, which I don't have the equipment. And this is electrolysis of water to turn water into the gases. Okay, so there's a battery. That's what gives it away. And just real quick, this is the physics symbol for battery. Represents the old different plates that used to be there. So if you see that up top, that is the battery. So if that was here, if this was this picture, that would be a battery. See any source of a battery, then that's going to happen. And still goes anode to cathode. Notice the direction flow always goes from anode to cathode, except for this time, they generally, you'll see that a lot of times they go backwards. The more from right to left rather than left to right, but they don't always go left to right. So you do need to be able to pick out the difference between anode and cathodes. So electrolytic cells use electricity to force this non-spontaneous reaction to occur. Non-spontaneous means it needs a little extra energy to get, like the activation energy from last unit. Okay, it needs energy to make it go. It's not just sledding down the hill. So if you see a battery instead of a voltmeter or a resistor, the voltmeter could be there. A lot of times instead of a voltmeter, you'll see a light bulb. A light bulb is a form of a resistor. So if you see a voltmeter with a V or a resistor like a light bulb, then it is a voltaic cell. If you see a battery, that is your Q. Okay, so now they flow backwards, hence the electroplating. The battery, this is the source of the electricity to drive the reaction. It's the source of the energy. Is perfectly stated, the source of the energy. It's why we need a battery. So what is the purpose of the battery in an electrochemical cell? That is the source of energy, source of electricity. There are some uses for these electrolytic cells. The production of H2 and O2 gas. So the electrolysis of water makes these gases. Well, we all know why we need oxygen. And H2 is a very, very efficient fuel source, hydrogen gas. Electroplating for precious metals, covering a reactive metal with a less reactive one to prevent it. This is cheaper than having pure non-reactive metals. So pure gold, non-reactive, very low on table J. If you take a mix of lead and some other metals that are kind of soft and heavy like gold, and then you just plate them with gold, you can sell them as gold, and then they're not as precious because the gold ends up wearing off. The inside metal starts oxidizing, it turns your fingers green. That's what goes on. So those like the cheap jewelry, where that'll turn your ears green or your fingers green, that has been electroplated using electrolytic cells. And then what we do all the time is plug our phones in. So boom, we recharge our batteries. Hold on, my phone is ringing. It's not real. But so charging the battery in your phone is a electrolytic cell completing the circuit and using a battery or an energy source like the wall to charge up the battery in your phone. It's just an electrolytic cell working backwards. And that should be the unit. And we're done. And that's really all you need to know about electrolytic cells, is that they need electricity to go because they're non-spontaneous. Everything else that we do happens with the voltaic cells, with writing half reactions and all the big business. So that's why voltaic cells I try to stress more, because in that regard, they are more important. Good luck with the rest of the unit. I hope everything works out for you.